welcome back to our course. Today, we will talk about reservoir fluid origin and the required parameters used to identify reservoir conditions. Let's jump on the details. In petroleum science, reservoir fluids are the fluids contained within the petroleum reservoir, which technically are placed in the reservoir rock. Reservoir fluids normally comprise liquid hydrocarbons, mainly known as crude oil, aqueous solutions with dissolved salt, hydrocarbon and non-hydrocarbon gases such as methane and hydrogen sulfide respectively. These fluids are brought to the surface as a mixture of oil, gas, and water, which is sent to a surface production facility before they can be disposed of or sold to an industrial customer. The formation of such fluids in the reservoir rocks begins in warm, shallow oceans that were present on the Earth millions of years ago. In these oceans, extremely small dead organic matter, classified as plankton, falls to the floor of the ocean. This plankton consists of animals, called zooplankton, or plants, called phytoplankton. This material then lands on the ocean floor and mixes with an inorganic material that enters the ocean by rivers. It is this sediment on the ocean floor that then forms oil over many years. The energy in oil initially comes from the sun. This energy from sunlight is trapped in chemical form by dead plankton. The formation of zafar fluid also followed the same path as other oil and gas reservoirs. Zafar fluid will originate from both the Ardebil and Karabakh reservoirs. The major part of the Ardebil content will originate from the Ardebil fifth horizon, along with some contribution from Ardebil second, third and fourth reservoirs. Karabakh fluids will consist of fluids from both the upper and lower horizons. Let's talk about reservoir conditions. Reservoir conditions are beyond the scope of chemical engineers. But it is worth to learn some information about the conditions of our main reservoirs, Ardebil and Karabakh. Generally, reservoir conditions are different and specific individuals to each reservoir. Two dominant variable conditions affect every petroleum reservoirs are pressure and temperature. Differences in fluid pressure and temperature between one area and another determine pressure and temperature gradients, which are fundamental to most problems involving the movement of oil and gas through the rocks. This movement may be a migration that permits oil and gas to accumulate to form a pool, or it may be a movement of oil and gas from a pool into a well bore. Much of petroleum engineering has to do with relations between pressure, volume, and temperature, or, as they are commonly called, collectively, private. The volume changes are most pronounced in the gas content of the reservoir, but they also occur in the other fluids, the water and the oil, and to a lesser extent in the materials that constitute the reservoir rock. Abnormal fluid pressure gradients and any temperature gradients indicate that energy has changed from potential to kinetic, and that work is being done. Apart from the pressure and temperature of the reservoir, TVD true vertical depth and GOR gas-oil ratio are also parameters used while defining reservoir condition. True vertical depth (TVD) is the parameter that is defined by measuring vertically from the surface down to a certain target downhole. The gas-oil ratio (GOR) is the ratio of the volume of gas that comes out of solution, to the volume of oil at standard conditions. As we defined all the required parameters used in defining reservoir condition, let's look at conditions of our reservoirs. As you can see from the table, Ardebil third reservoir operates at 251 bars and 60 degrees Celsius with 1250 gas-oil ratio and from 2,300 meter vertically below the surface. You can also analyze the conditions of our other reservoirs from the table provided. Note that all above GORs are nominal figures and are a conservative design basis. The GOR will vary throughout field life. Alright, let's summarize what we learned in this lesson. First we talked about the significance and formation of reservoir fluids and then discussed the parameters like TVD, GOR, pressure and temperature that are needed to characterize reservoir condition. I hope you find out how mysterious are reservoirs. See you soon in the next lessons.